If a square brackets of x denotes the greatest integer less than or equal to x, that means in order to know this value, we need to know what is the value of x. We calculate the square brackets of x depending on this value according to this definition. The question is the square bracket of x equal to 0? And we are given two statements with two inequalities that establish the possible range of values for x. Okay, how can we analyze this without making it too complicated? Well, the best way is to use the definition to reinterpret the question given here. Since the square bracket means the greatest integer less than or equal to x, this question might be reinterpreted like this. Is 0 the greatest integer less than or equal to x? This question actually requires a yes or a no for an answer. How do we know if 0 is the greatest integer less than or equal to x? Well, let's see one statement at a time. We know that what the first statement says about the possible values of x is something that we can easily visualize on a number line. We have here the pivot values 0, 1, and -1, and that means that x might be any possible value in this range, without, of course, considering the ends of that interval. So, if we cannot consider this possible value, neither this possible value, right? Any value in between is okay. For example, let's say that we pick this as the value of x, 0.5. This is our x. Let's ask the question about value 0.5. Is 0 the greatest integer less than or equal to 0.5? Yes, it is. 0 is the greatest integer to the left of 0.5. So, with this value of x, the answer to the question would be affirmative. Okay, let's try 0. If x were 0, is 0 the greatest integer less than or equal to 0? Yes, the answer would be affirmative again. Okay, so far so good. Okay, let's try a value here. For example, -0.5. If this were x, is 0 the greatest integer less than -0.5? Actually, no, because 0 is greater than -0.5. It couldn't be the greatest integer less than, neither equal to. So, with this value, the answer to the question is simply a no. So, clearly, this is not sufficient. What about statement 2? Well, statement 2 says that x is less than 0. If x is less than 0, then we can visualize this on a number line, 0 here, a few pivot values, for example, negative integers, -1, -2, and -3, and we can continue assuming possible values for x. For example, x is this value here, -0.5. Is 0 the greatest integer less than or equal to x, that is to -0.5? Never, because 0 is greater. It's not the greatest integer less than -0.5. The greatest integer less than -0.5 would be -1. So the answer to the question here is a no. If we pick -1 as our possible value for x, 0 is not less than -1. So again, we have a no. And a value intermediate between -1 and -2, -1.5. What would be the greatest integer less than -1.5? Clearly, it would be -2. So again, the answer to the question with this value would be a no. If we assume that x equals -2, the greatest integer less than or equal to -2 would be -2. So again, the answer is no. We see that no matter which negative value we pick, 0 can never be the greatest integer less than or equal to a negative. So here we have a unique answer to the question, and that it means sufficiency. Correct answer here is option B.